Good evening, everyone. A warm welcome to all present in this meeting. On behalf of the Department of Mathematics at Wilson College, I firstly wish everyone a very happy new year. And I also heartily welcome Ajay Kumar sir for his first session in this IIT Jam Mathematics lecture series, which is organized under the DBT STAR Strengthening Scheme. Sir is an assistant professor at KR Mangalam University in Gurugram. His areas of interest are in fluid dynamics and differential equations. Sir, thank you for taking out your valuable time to share your expertise. I now invite Sir to start his session. Thank you.
Hello.
Yes, sir.
Okay. So, good evening to all. So today I welcome all the students and I thank the host ma'am and the college for providing me this opportunity to give lectures on the topic differential equation for IIT JAM. So students, I go to my presentation. So in starting, this is, so first of all I introduce myself. So currently I'm working as an assistant professor in Mangalam University, and I did my graduation from University of Delhi and MSc from IIT Madras. And I also was a part of you students and preparing for JAM exam in 2017. And after that, I did my PhD. Like, yet Viva has to be completed from SVNIT Surat. So today in our lecture, we are going to learn about ordinary differential equation part that is covered in our IIT JAM exam. So number of questions, like it is almost 8 to 10 number of questions are there. So average marks of for this part we can cover about 12 to 14 marks. Like students are there, right? Hello. Hello.
Hello, sir. We are listening.
Yeah. Be attentive.
Yeah, sir.
Yeah, you can reply whenever you feel like there is some query or something, like you can raise your voice and ask me.
Obviously.
Okay. So we have in our IIT JAM syllabus, separation of variable, Bernoulli equation, then exact differential equation, integrating factors, orthogonal trajectory, homogeneous differential equation, second order linear differential equation, variation of parameter, and Cauchy-Euler equation. So we will try to cover all this in 4 lectures. So what we will cover in lecture 1 and 2. So we will cover basics. So what is differential equation types? What is order? What is degree? And also we look for the solution of first order and ODs, like separation of variables, exact differential equation, integrating factor method, and Bernoulli's equation type as well. So this is your syllabus for JAM exam for this topic ordinary differential equation. So here we have number of equation 8 to 10 and average marks are 12 to 14. So this almost covers this part of separation of variables that I already told you earlier. And these are the topic that will be covering. So here we go for definition of differential equation. So everyone knows what is differential equation, right? So you can tell me here what is dependent variable and what is independent variable.
Here x is independent variable and function of x, which is y of x, which is depend on x.
Yeah, and here?
Here independent is x and y both are independent, but as a function u is depend on x on y.
Okay, fine. So ordinary involves only one independent variables. Like we can see here, this is the example, dy by dx plus y equals to ex, right? And when we involve like more than one independent variable, then it becomes, the derivatives becomes like partial derivative, and we define partial differential equation, right?
Yes.
Yeah, so this part you will look into your MSc classes, and only as a part of JAM exam, we will cover ODE. So what is order and what is degree? So order is the highest derivative part that is present in any differential equation, ordinary type. Okay, so here, what is degree? Anyone? Like only one participant is
Degree
there?
is 3, I think. The highest order of the differentiation.
Order is 3.
Yeah, that's the trick. Order is 3 and degree is 1. Okay. Order is the highest derivative. That is d cube. It is 3 time derivative, right?
Yes,
Yes.
sir.
Yeah. And degree is the highest power of that part. That it is provided that the equation should be free from radicals, fractions, and transcendental functions of derivatives, like here. So here, what we can say order? What is order here?
Order is 2,
And degree?
degree is 3.
Okay. So order is defined always. Like for a difference given ordinary differential equation, is order defined always? Can anyone tell? Oh, you
Here
can try
order
like yeah.
order is the mm, highest term of the, I think, if it is first order derivative and indices of the highest order derivative is the order, I think.
Okay. My question is like, is order defined always? Like we can define always an order for a given differential equation. Like here, for example, you can take here sine dy by dx plus y equals to 0, right? So here order is defined.
No, because it should the polynomial in function, I think.
Here order is fixed, no? Like dy by dx is order. Here's the problem. Like you know the expansion of sine x, right?
Yes, yes.
What it is?
X minus x cube by 3 factorial plus x to the power 5 by 5 factorial, something.
And so on. Okay.
Hmm.
So when we try to expand this sine dy by dx, right? Or I can write sine y dash. But if we can write it, sine y dash is equal to y dash minus y dash power cube by 3 factorial plus y dash to power 5 by 5 factorial, and so on. Okay. So here we can see the order part is 1 here. In all terms, it will remain 1. But for if it's a degree, so for degree, like it is going like up to infinity, right?
Yes,
Yeah. So in some cases, so here we can say order is 1, but degree is not defined. You got my point?
yes, it is clear.
Okay. So now there are practice questions. So everyone should try. I must say like how many participants are there? Total 16 parts. So I think that everyone should answer, like try to answer like will be the order and what will be the degree here.
In first case, order is 2. Oh, sorry, order is 3, and degree is not defined, I think.
No, degree is one actually.
One.
Degree is 1 and order is
Degree order is 3.
okay. So
But
we have to take
sir,
like
degree here, it is half
yeah. So what we have to do? We have to do the
squaring.
square. Yeah, square.
Yeah,
Like
yeah.
you
Okay.
can take this as minus d cube y by dx cube to the power half, and you have to square both sides. Then it becomes power 1 and it is power 4. Okay. So here what you see order is highest order derivative, that is 3, and what you look for power, sorry, degree. So that is power of the highest order derivative part. So what it is, it will become plus on squaring. So it is 1, right? Anyone, like, you got my point, right?
Yes, sir.
Hello. Yeah. Okay. Now shift to the other audience. I would like to know the answer of this second question. What is order here and what is degree?
Order is 4, degree is 3.
Order is 4 and degree is 3. Okay, correct. And any other one from the audience, order and degree for this fifth question?
Order is 2 and degree not defined.
Okay, fine. Good. And what about this other student?
So can I?
And you? Yeah, sure.
Order is 3, degree is 1.
Order is 3 and
Degree is 1.
degree is. Why you think degree is 1 here?
So when we shift y to the right side and when we take log on both sides, then degree will be 1.
Okay. Okay, powers. But what if we take expansion of e ki power x? What is expansion of e ki power x?
Yeah, that will be a series, but the question will be different at that time. So basically, our aim is to make expression in such a way so that degree will be defined. And if we are not able to find such expression, then
Mm-hmm.
degree is said to be undefined. But we are here, we can get some such expressions for which degree will be defined.
Like
So
here also we can do the same thing. D square y by dx square plus y equals to equals to minus y, sine of inverse of minus y, right? According to you, we can also define like this. Okay, so for that part, it should be free from radical, like transcendental, it should be free from transcendental function of derivatives. So your derivative is in power. Okay, so we have to go for like e ki power expansion of e to the power x, like this. And so here degree is got my point.
yes, sir.
Okay, so
Sir,
now
actually, I have a doubt. Can I ask?
yeah.
Sir, the D, sir, up to class 11 and 12, there is
Mm-hmm.
given that the when we define degree, it should be in the polynomial form and not in the series form. And
Mm-hmm.
the power of the derivative should be in the natural power. But sir, there is one another definition of degree is that the power of the derivative,
Mm-hmm.
the highest, degree is the highest power of the highest order derivative. So when we expand exponential, like e
Yeah.
raised to the power d3y dx square, so
Mm.
whatever the whatever the power of d3y over dx square,
T cube, yeah.
the Yes, sir.
Mm-hmm.
Uh,
So it will be like this, no? D cube y by dx cube to the plus a cube y by dx cube to power square by 2 factorial, and so on. Like somewhere it is 1 upon n factorial d cube y by dx cube, oh sorry, dx cube to the power n, and so on. So here like power is increasing, this is going up to infinity. So we can't take the highest power of that derivative term. So we actually can't define here the degree. Okay.
okay, sir. Got it.
Yeah. So in third question, what is order
Order is 2, degree is 1.
in degree? Yeah,
Degree
degree
is
is 1.
1.
Okay. Okay, fine. So okay, next we move to first order and first degree differential equation. So general form of first order and first degree differential equation is this: dy by dx is equal to some function of x and y. Also, it can be written as like function is something like f of xy can be taken as e of xy upon b of xy. Then, or it is like b of axy. So it can be written in this form as well. So these are the examples of first order and first degree differential equations. So here degree is 1 or 2.
Degree is 2.
Yeah. So it is second. This is first order and
Second degree differential equation.
second degree. How?
No, sir. Previous one.
Yeah, this one. Yeah, this one. Okay, okay. Yeah, your voice is lacking actually. So for this one, last part, order and degree.
Degree is 1. Order is 1.
Yeah, okay. Okay. Next, we will see how we can solve first order and first degree differential equation using separation of variables, exact differential equation type, what is integrating factor, and what is Bernoulli equation. These are already covered. I actually the student had, but I wasn't informed earlier about this. So we will try to recall only. And next lecture, I will go for that the remaining part that you are left out with. So what is separation? So standard form, if we take this dy by dx is equal to some function of x into some function of y, that is gy. So this can be written as a like function of y in one part with dy and function of x with the dx. And what we can do, what we do next, we just integrate and here we get the solution, right? Right? This is right?
Yes, sir.
Yeah, and what is like here it is left the constant of integration. Okay, so remember this thing. So now we will go look for one example. So you already covered this part. So what will be the final solution? Everyone should try on their own and tell me the answer.
So y is equal to x cube by 3 x plus c.
Y equals to
X cube by 3
yes.
x plus c.
Okay, okay, fine. Okay, so it is correct. Anyone? Any other student?
No,
Yes, yes.
y square by 2 is equal to.
Yeah, here is
Yeah.
the part
Yes, sir.
you
Y
missed.
square.
So while looking for 4 options, no, you have to be like attentive. Like here, if you like got this option and you just correct like this, and you got minus 0.33 marks for that question. Okay, so be like attentive doing all the questions in exams. So it is like y dy, like those students who are not able to do this is have to Hello, am I audible?
Yes, sir, you are audible.
Call, I will tell that there is no problem, but one thing you have to do is that matters. Okay, so like can you tell me what is the exact differential equation? Okay, no issue. Like I'll tell you. So when we have a differential equation of this type, okay, so when we say this equation is exact, when partial derivative of m with respect to y is equal to
Del m del y
partial
equal to del n del x.
del x, right? Okay, so this is equation is exact if and only if this condition holds, right? So if I say xy dx plus so is this equation exact?
No, sir.
Why? So here it is m.
Yes, sir, it is exact.
Yes, sir.
Yeah, it is exact. Like
The partial
it is
derivatives
exact.
are equal.
So here partial derivative with respect to y, what it is?
X.
X, and here
It is also x.
it is also x,
Del
na?
x of
2x
x
by
square
2.
by 2.
So it is x. Okay, so now this is exact. This is right. Now let me do eraser for. And once you know that this is an exact differential equation, how you plot, like how you define its solutions? Anyone? I
Sir,
say
we
like
can.
star is our. I'm saying that it is exact equation. Then how you define its solutions?
So we will integrate m, treating
Yeah,
y as constant,
yeah, treating y as constant.
and plus we will integrate those terms of n which are free from x,
Free from y.
free from integration
X.
n dx, free
Dy.
from y, free from x.
Yeah, yeah. Is equal to
Yes,
c.
sir.
Right?
Is equal to c. Yes, sir.
So what we have taken the example, it is x by dy plus x square by 2 dx equals to 0, right? So what will be the solution for this? Integrate x, y, dy and terms free from x. So I have written the correct thing, this terms free from x, or it is terms free from y? Anyone? It is the correct form?
Yes, sir.
Yeah, so here terms free from x. So here there is no term is equal to c. X y square by 2 equals to c. This is the differential equation, right? You can check as well, like what we do if we differentiate d of xy square by 2 equals to c. So this is total derivative. So for once we have to do derivative with respect to x, and once we have to derivative this with respect to y. So when we derivative this with respect to x, what it is? It is y square by 2 dx plus when we do derivative with respect to y, it is 2y x by 2 dy. So it is 2y square by 2. So terms free from x. What we have missed? Anyone? X square by 2. Anyone can find the error here? Anyone? Like I made a mistake. I know. Can anyone
Sir,
see where?
you took the x square by 2.
Yeah. We have taken
Mm.
like this term in back, and like we have processed the whole. We have to solve like this. So first we have to take x square by 2 dx plus xy dy equals to, and now we have to use this formula, right?
Yes, sir.
Yeah. So here it is like this type of error can anyone made. So you have to here it is x square by 2 terms free from x, that is no term, that is here equals to c. It is nothing but x by 2 xy dy x cube by 6 equals to c. Again, there is something missing.
Sir, actually, the question is not exact. The question you have written, that is not exact. When we do my, it is 0, and nx we are getting y.
Question is exact first. 0. Yeah, and del n upon del x, it is y. So our equation is not exact. So here, this is not the solution. So for that part, what we do, we need integrating factors to make equation, the given equation, exact differential equation. Okay, so like in starting, we already made the error. It is actually xy dx plus x square by 2 dy. Okay, then it will go like the solutions that we did earlier. We can take this example after this. Okay, we can take this here. So plus x square by 2 dy equals to. So now check whether this equation is exact. So this is del m over del y. What it is?
X.
Anyone? Yeah, x.
It's X.
You can write like this xy. This is x. What is del n over del x? This is our n.
2x by 2 equals to X.
What it is? 2x upon 2. So now the equation is exact, right? Yes or no?
Yes, sir.
Yeah.
Yes.
So now the solution for this part will be xy dx plus y taken as constant and x square by 2 dy and terms free from x. Okay, so we can't take this term is equal to c. So what we have? X square by 2 of y equals to. Is this point clear or not?
Yes,
Yes,
sir.
sir.
Clear.
So also we can check like the last part. If I stop here, like I haven't checked that we find the solution and I haven't checked that what we have got is correct or not. So here we can check as well. Like you have to do derivative on both sides. t of x square y upon 2 equals to c. So one time you integrate with respect to x and one time you integrate with respect to y. Okay. So what it is? So when you are differentiation. So when you are differentiating with respect to x, what it is? X, y. Correct or not? It is 2x into y upon 2, right?
Yes,
Yes,
sir.
sir.
And what is when we do with respect to y? Differentiation with respect to y? It is.
X square by 2 dy.
And what is that?
0.
Differentiation of a constant is 0. So you can also check. This is the same differential equation that we are using to solve. Okay, so this is the solution of, this is the back part. We can verify here. Okay, so this part is clear to everyone?
Yes,
Yes,
Yes or
sir.
no? Okay. So now we come to part this integrating factor. So all we know what is an integrating factor. So when we have a non-exact differential equation, like what we say, like when we say the differential equation is non-exact, exact, anyone?
When my is not equal to nx.
Yeah, like in short, you are writing my is not equals to nx. Yeah, this is
Yes, sir.
okay. So to make it exact differential equation, what we introduced integrating factor. So when integrating factor, what it is like, we there are like 5 method I have discussed here. So when you multiply this by whole equation, so now this whole equation becomes exact. And you have already studied what is integrating factor, all methods. Let me recall you, like what is go by types. So when we have mxy and nxy as a homogeneous function of same degree, then integrating factors are in the form 1 upon mx plus ny. So first condition why we are finding, when we are finding integrating factors, when our equation is non-exact, that is my is not equals to nx. So type 1 involves integrating factor when our, what we say, mxy dx plus nxy dy equals to 0, when m and nxy are homogeneous function of same degree. Can anyone tell what is homogeneous function of n degree? What, when we say this fxy is homogeneous function of n degree? Anyone? Okay. Let me tell you, f lambda x comma lambda y equals to lambda to the power n f x y. Okay. Like if we say 2xy plus y square. So what we say, this function is of which degree? Homogeneous function of which degree?
second degree.
Yeah, second
Sec-
degree. Fine. Okay. So here is the example. So here first we have to check whether this equation is exact or not. So del m upon del y. What it is? X square minus 4xy. And what it is? Del n upon del x. That is 3x square minus 6xy. Right? Is this correct or not? I think this will be plus and this is minus.
Right, sir.
Right? So here we can say integrating factor, it should be provided that mx plus ny should be non-zero. If it is sometimes it becomes 0, then integrating factor, like you have to check whether which one is fitting the best part, you have to check, like you have to check individually which one is like integrating factor for that particular given differential equation of first order. So here integrating factor we can say mx plus ny. So what it is, 1 upon mx. So you have to multiply. This is your m. Yes or no?
Yes, sir.
And this is your n. So you directly x cube y minus 2x square y square plus ny. Plus ny you have to involve this sign as well, okay? Minus ny, that is x cube y plus 3x square y square. So this thing cancel out, and this is 1 upon x square y square.
Right.
So this is the integrating factor here, right?
Mm.
Yeah, so here this type comes from here. This is part like homogeneous function of same degree. So here you can say this is third degree, and this is also third degree, right? M and N. Okay.
Yes, sir.
Like, hello.
Yes, sir. It's okay.
Yeah, okay, fine. Now second part. When we have type like the given differential equation is of the form this type: y into some function of xy and x into some function of xy dy. Like here what we can write, 1 plus xy dx plus x, if we take common it is 1 minus xy dy equals to, right? This is of this form, y into some function of xy, x into y, and here x into some function of xy, right? So here you can directly find integrating factor as 1 upon mx minus ny. So this becomes xy 1 plus xy minus n, that is xy 1 minus xy.
So 1 by
So
2 xy we are getting.
1 by 2xy. Okay. So this will be directly, we can go like from here to here, we can directly find our integrating factor. So like you directly receive this type of question, find the integrating factor for this differential equation. So you have to classify the types. So one type is the homogeneous part, and second is this form of this y into some function of xy and x into some function of xy. Okay. And then type 3 comes when you have a del n upon del x minus del m upon del y, 1 upon m. So when we are here using m, okay, so m involves a partial derivative with respect to y, so it should come function of y. Then you can directly say the integrating factor will be f by dy. Okay. And when you have function of this type, del m upon del y minus del n upon del x, so here it should come n. So n is partial derivative with respect to x.
Function
You
of x.
ठीक है, like okay. So here it should come function of x, and keep it in your mind, like sometimes it also can be written as minus 1 upon n del n upon del x minus del n m upon del y. So keep in mind that when you have a function of like, when you are having this m here and m here, and it should be after minus sign, and here the function, if the what is the partial derivative part, the time is partial derivative with respect to y, so it should come function of y. And in this part here we are changing n only, n, and it will be like n is like here it is mx, sorry, my equals to nx. So n is associated with this x, So here it becomes, it will come function of gx. So what is integrative factor in this case? E of gx dx. Like this point is clear? Like sometimes you like mix up between these two cases. Okay?
Yes, sir, clear.
Yeah, so here now you can see what it is. It is xy dx and 1 plus x square dy. So m n. So my. What is this my? X and n x. What it is? 2x. Okay. So you can see my minus nx is some function of x. Right? Minus x. Okay. So you can see like if I divide it by 1 plus x square, yani 1 upon n. My minus nx will be, it is nothing but minus x upon 1 plus x square. So this is function of x. So integrating factor in this case is minus x upon 1 plus x square dx. This part is clear to you, all of you or not?
Yes, sir.
Yeah. So here you can integrate it easily. Like you can make substitution 1 plus x square is equal to t. What should I do? You can do it, right? Okay, let me write it. 2x dx dt and then
1 by root over 1 plus x square.
e to the power minus, it is dt by dt, right?
Yes,
2t. So it is minus ln t to the power half, or you can say e t to the power minus half ln. So it is e to the power ln t minus half. So you can directly written this
e
as
to
t to
the
the power minus half. So what
minus
it is?
1 by root
1,
over 1 plus x square.
yeah, 1 by root 1 plus x square. This is the integrating factor for this example, right? So similarly, you can go for this case. So we have actually did the next case, function of x. So you can try this. You can take screenshot. You can try this example at your own. This is similarly the type 3 that we have already discussed. I covered there on this thing. You can take screenshot. You can try this at your own and try to find integrating factor here. Okay. So next, moving integrating factor in the form x and y. When we can't classify the given differential equation, first order differential equation, from these 4 parts, then we can see like here in options it is x y to the power minus 1, y x to the power minus 1, and here it is x to the power minus 1, y to the power minus 1. So we can using that hit and trial method, like x to the power m, y to the power n. So we can find m and n here. Okay. So what we do, anyone can tell in this case what we will do to find a integrating factor?
So first we can multiply x to the power m into y to the power n to the given differential equation.
Yeah, so given differential equation, we have to multiply this thing to x square y. Then we can directly add the powers, right?
Yes, sir.
Y to the power n plus 1, then plus x to the power 1 plus m, and y to the power 2 plus n. This is our m thing. And what will be n? X to the power 3 plus m, y to the power n, and x to the power 2 plus m, and y to the power 1 plus n, right?
Yes, sir.
Now you have to do del m upon del y. and del n upon del x. And what you do?
So we will
You make
equate the
them,
coefficients of similar power.
yeah. So you can do like you have to equate, and you have to equate the powers,
And we can find out the values of m and n.
and then you have to find the values, and you can find the what will be the
Yeah.
correct option.
Integrating
Okay.
factor. Yes.
Yeah, you can easily find using this. Now we have a linear differential equation. So you all know of this type of linear differential equation. Integrating factor is e to the power integrating px dx. You can also check this is the integrating factor, like e to the power integration px dx plus px e to the power integration px dx into y equals to qx u by dx. So what you do? E to the power integration p dx dy plus I am taking this thing in opposite side minus px e integration px dy dx into y plus qx e integration px dx, and what do you multiply here? Tx, right? And you can like check this thing is n and this is your m. You have to take this thing in right hand side. Okay, so this is minus m dx plus n dy equals to 0, and I say this as m star. This is our m. Okay, you can check. Now the equation will become exact, and you can easily have the solution of this type of equation in this form. Y times integrating factor is equals to integrating qx into integrating factor, and adding a constant of integration, right? You all know this type of linear differential equation and its solution of this form, right? You can cross verify it. It will go like this, but exam point of view, you only need to solve this equation using what is integrating factor here, e to the power 1
Integral
e.
pxt.
Okay, so and what will be the final solution? Y into integrating factor, what is qx here? Ex into what is integrating factor? Ex, and what is this qx? So ex into ex, these are same, so plus c. So it is nothing but ex plus x, e to x,
It,
right? So it is nothing but y ex equals to e की power 2x upon 2 plus c. It is the final solution. Okay. If you want to know the process, like proof process, you can proceed like this. Otherwise, if you don't want to, you can skip. But you should keep these in your mind. So what will be the integrating factor, what is its type, and what is the final solution? Okay.
yes, sir.
Okay. Yeah. Now the last part is that is Bernoulli equation. You all are aware of about this. So tell me what we have to substitute here, like Bernoulli equation of this type. What we do here? Anyone can tell.
So we will divide the equation by y to the power n.
Okay. Y to the power n. So this is okay. Now
And then we will substitute y to the power 1 minus n equal to z.
equals to
Z.
okay. So here it is this y to the power 1 minus n. So it is y to the power minus n y dash plus y to the power 1 minus n. This is 1, okay? Not dash. Px equals to qx. So what is like 1 minus n y to the power क्या आता है यहाँ पे? What it is? Y to the power minus n.
Yes, the minus n dy is equal to dz.
Right? So you can what you put dy equals to replace dz by 1 minus n y to the power minus n. That is nothing but tell me what we do next. Anyone like what we do next? Is it correct till now? Okay. So what we do, y to the power 1 minus n z into px equals to qx, and you put dy equals to dz by dx and 1 upon yn, and what it is 1 minus n y to the power minus n here. Okay, so this becomes y to the power n minus n will be like it is y to the power 0, that is 1 dz by dx plus z px equals to qx. Is this part clear? And
Yes,
this is dz by dx plus 1 minus n into z. Sorry, you can write px and z equals to qx. So this is our the same this thing linear differential equation that we have discussed in last slide. So here this is function of some x into y. So here it is changed to z. Okay, and yeah, here it is changed to z. So this is some function, you can say p star x new function is equal to qx. So again you have to follow the same procedure that we have did earlier to get the solution of this differential equation. This much part is clear to you, all of you?
yes, sir.
Yeah. Also, like when n is 0, this equation will be Bernoulli equation.
It will be linear differential equation.
Yeah, it should reduce to linear differential equation.
Linear
When what?
differential.
Yeah, and one n equals to 1, what it is? Again, it is reduced to
Again,
our
it is
yeah
linear differential equation.
yeah
Which-
because this pxy equals to some qxy. So it like some gives some new function like minus q
px
x o.
plus minus qx.
Yeah, px minus qxy. So you can say this p star x y. Okay. So this again reduced to that earlier part, this linear differential equation. And here it is up to Bernoulli equation. Everything is, I think, almost I recalled a lot. Now for this thing, these are the previous questions. So I can share the like this slide of questions so that you can go through practice. So practice it and try to like while solving, try to maintain the limit, like what time you are using in solving a single question. Okay, what time you are using, like anything else like that I can tell if anyone have doubt from this current session today. So I'll share this with the hostman, or if you try like I can share and I can discuss in the next upcoming sessions. Like anybody can respond.
So
Is
we
it fine?
can try all these problems, and then if we are unable to do some problem, we are stuck at it, then we will tell you in the next class.
Okay, fine. Okay, so like host ma'am is there?
Yes, sir.
Yeah, ma'am.
You can share it with us. We'll pass it on to them.
Okay, ma'am. Okay, fine. So in one student can answer like in next session, what you would like to cover, like which topics? Any student can tell like what topic is you like stuck in or left out in this part of differential equation, GEM syllabus.
So orthogonal trajectories
Okay. And
so finding out a complementary function, not complementary function, but basically different cases of particular integral.
okay, complementary functions and that particular integral part, right?
Hmm.
Okay. Anything else?
And the method of variation of parameter.
Okay.
And so linear differential equation with constant coefficients and variable coefficients.
Okay, fine.
And so do we have questions on reduction to normal form in JAM exam? Is it included in the
Reduction,
syllabus?
like reduction to normal. I think I have to see. There are no questions for like reduction to normal form.
Yes, I have not seen any.
Yeah. So in like syllabus, I think I haven't seen this in syllabus as well.
And so Wronskian,
Wronskian, I think there is not in IIT JAM exam. It is in NET exam actually.
but I have seen
As far as I
questions on
call
this
recall,
topic. There are questions on Wronskian.
in JAM exam.
Yes, sir.
Okay. Then I will look for it, like, and I will cover that part as well.
And
And anything else? Okay, ma'am.
All right. So thank you so much for this interactive and engaging session. And thank you, participants, for patiently attending the session, today's session. Next would be tomorrow, same time.
Okay, ma'am. Thank you.
See you all then. Thank you.